Hello, hello. It's time for another video on e-learning. And today I'm going to do the Unit 9 study guide on gas law. So I'm going to split this video into 3 separate parts because there are 3 separate days. Alright, so for the first day, I'm going to do just the questions. Then the next day I'll do the first set of practice problems. And the next day I'll do the third set of practice problems. So I hope that your e-learning is going well. I have been doing a lot of reading, hanging out with my dog. I posted a picture of him on the Google forum. He's a gigantic chocolate lab, and he loves playing Frisbee. So, let's get started on these questions, and I hope these videos are helping if you're watching them. Alright, so, like I said, I'm going to do the first set of questions, and there's about 15 questions. Yeah, 15 questions. Alright, so now the biggest question of all is, which color do I pick? Oh, I really like this one. It's a dark blue. Alright, so what causes pressure in gases? What is pressure? Alright, so pressure is caused by the collisions. Alright, so collisions, and I always spell collisions wrong. Collisions, I think that's right, of gas particles with each other and the sides of the container. Alright, so as you probably know, the gas particles are constantly, bouncing off one another, bouncing and bouncing and bouncing everywhere. So this causes what they call pressure, and pressure is just a force. Pressure is a force per unit area. And I don't know if you can hear that or not, but my computer sounds like it's like a jet plane. It's about to take off. I guess the fan's running or something. Alright, what units are used to tell pressure? Alright, so there are 5 of them. The first one is millimeters of mercury. Alright, or mmHg. Alright, the next one is torr, which is exactly the same as mmHg. And that one was named after Evangelista Torricelli. Remember the guy who made the first barometer? Alright, torr doesn't really have an abbreviation. The next one is my favorite one, which is atmospheres. And that one is abbreviated ATM. Alright, after atmospheres, we've got one that is common in your tires, pounds per square inch. That's abbreviated PSI. And then finally, we've got this last one. It's called kilopascals. And the abbreviation for that one, KPA. Alright, so it says, oh, and look at number 3. Fill in the blanks with the correct numbers. Alright, so if you had no idea about number 2, you could have just, looked at number 3 and said, oh, look, here's most of the conversions. Alright, so 1 atmosphere is going to be equal to 760 torr. 1 atmosphere is going to be equal to, the magic number here is 101.3. The next one is, again, 760. And then 1 atmosphere is going to be equal to 14.7 pounds per square inch. And I'll give you all of these on like a test or something like that. Alright, finally, what is a barometer? What does a barometer measure? A barometer is a device used to measure atmospheric pressure. So I kind of answered both of those in one sentence. So a barometer is, the first barometer was built by this guy named Evangelista Torricelli, and what he did was he took a pool of mercury and he saw how much or how high the mercury column rose when atmospheric pressure pushed on it. So the people on like WYFF and stuff like that, they're using barometers to tell the air pressure, and usually you'll see the air pressure, it'll be like around 30 inches of mercury. And the reason that they use inches of mercury instead of millimeters of mercury is because we use the English system instead of the metric system. So the English system is things like inches, feet, yards, all those kinds of things. And then the metric system is like meters, liters, grams, millimeters, centimeters, and all that kind of stuff. Alright, what can you do to increase gas pressure? Alright, so increasing gas pressure is pretty easy. The first thing you can do is you can decrease the volume. You can make the container smaller. So decrease the volume, that's one. The second one, you can heat up the gas. You can make the gas hotter, and as the gas gets hotter and hotter, the gas particles collide more, which will then increase the pressure. Number three, you can add more gas. Alright, so if you wanted something like a water bottle or something like that, you wanted it to, explode or something, you could just keep pumping more gas in, and that would cause the volume to increase until, it can't hold anymore. Alright, so number 6 says, what does Boyle's law state? And Boyle's law is the first gas law that we talked about. This is the formula for Boyle's law. P1V1 equals P2V2. And it says, as the as the blank of a gas goes up, the blank goes down. So as the volume of a gas goes up, the pressure goes down. Alright, this is the only gas law that is indirectly proportional. Alright, so indirectly proportional just means as one thing goes up, the other one goes down. And if you probably can't see me, my hands. Usually in class I do this thing where it's like one goes up, the other goes down. So that's kind of the way that I always think about it in my head. Alright, so number 7, it says, what is the temperature system called Kelvin? So Kelvin is a temperature, I'm going to abbreviate temperature as temp, is a temperature system invented by scientists that has no negative numbers. Alright, the lowest number that you can get in Kelvin is 0, and 0 equals absolute 0. And absolute 0 is one of our vocabulary words for this unit. Alright, so the next question is, how can you convert Celsius to Kelvin? Add 273 to Celsius temperature. Alright, so if you want to go from Celsius to Kelvin, you just add 273. If you want to go from Kelvin to Celsius, just subtract 273. Alright, number 9, it says, what does Charles's law state? Charles's law is going to state as the temperature, I'm going to run out of space here, of a gas goes up, the volume goes up, and vice versa. So the formula for this one is going to be V1 over T1 equals V2 over T2. And to solve this one, you're going to cross multiply. And you don't have to write in all of this. I'm just giving you some extra information. Alright, so you cross multiply to solve. So you go here, and then you go here, kind of like that. Alright, so that was Charles's law. That was the second one. Remember the guy's name was Jacques Charles, or Jacques, or however you pronounce it in French. Alright, number 10, it says, what does Gay-Lussac's law state? Alright, Gay-Lussac's law is going to state as the temperature of a gas goes up, the pressure goes up, and vice versa. Alright, so here's the formula. P1 over T1 equals P2 over T2. Alright, and again, you're going to cross multiply to solve that one. So cross multiply to solve. Alright, so if you notice number 9 and number 10, Charles' law and Gay-Lussac's law, they both deal with temperature. And in order to do these calculations, you have to convert the Celsius temperature into Kelvin. Alright, so remember, to convert Celsius to Kelvin, you just add 273 to the temperature. Alright, number 11. It says, what was the formula that scientists came up with and called the combined gas law? Alright, so the combined gas law, all they did was they just combined all three of these. They combined Boyle's law, Charles' law, and Gay-Lussac's law. Alright, so here's the formula. P1V1 over T1 equals P2V2 over T2. And again, it's the exact same process. You're going to cross multiply to solve this one as well. Alright, so again, you go here, and then you go here to solve these. So you're just going to cross multiply like that. Alright, so remember, if I'm going too fast for you, or if you want, more time to write, maybe I write too fast and you can't keep up that way, just click pause on the video, finish writing down the stuff, or you can finish typing it. Some people have said that they have my video open in one window, or like one side of their screen, and then they've got the Google Doc on the other side of their screen, and then they just type in as I talk, or type in whatever I write down. And that's perfectly fine. You can do that as well. Alright, so I'm going to move on to the next page. Alright, and it's asking about Avogadro's law. So Avogadro's law was, it states that basically as the amount of gas goes up, so does the volume of that gas. Alright, so here's the formula for Avogadro's law. It was V1 over N1 equals V2 over N2. Alright, and remember, the N was amount of gas in moles. Alright, so I know that you all love moles so much. So remember Avogadro, he had that number, and that's how we converted from number of particles or number of atoms to moles. I know you all love that so much. So anyways, Avogadro's number, 6.02 times 10 to the 23rd. Hopefully you remember that. And that's pretty much it for, all the gas laws that have to do with people. Alright, number 13. 13 is something that we didn't get to in class, but I feel like you could piece it together all on your own. So what is the formula for the ideal gas law? I'm going to write it over here, just because I've ran out of space right here. So PV equals nRT. So PV nert, I guess that's how you can remember it. PV equals nRT. And all this has done is it has combined all of the gas laws that we've talked about thus far. It combines pressure, volume, N, which is the number of moles or the amount of gas, R, which is this gas constant, which I'll talk about here in a second, and then T, which is the temperature. Alright, so P is going to be pressure. Alright, and I just want to make a distinction about the ideal gas law. So for the ideal gas law, the pressure, volume, temperature, and the amount of moles, they have to be in certain units. So pressure has to be in atmospheres. It has to be in ATM. Alright, the V stands for volume, and this has to be in liters. Okay? Alright, N is the number of moles, and of course that's going to be in moles. R is the gas constant, and it's always this number, 0.08206. It's always going to be that number. So you can always just fill that in whenever you have it. And then finally, T is going to be the temperature, which has to be in Kelvin. Alright, and so number 15, it says, what temperature system do all temperatures have to be in to use the gas laws? It's Kelvin. Alright, and to get from Celsius to Kelvin, add 273 to the Celsius temp. Alright, and that S looks weird, so I'm just going to try to fix that. Well, it still looks terrible, but that's fine. Alright, so hopefully you enjoyed this video. Again, remember, if you have questions, please send me an email, comment on Google Classroom or something like that. The next two videos are going to be about how to do these practice problems, so stay tuned for that. Have a great day.